There's lots of different things that firms could be anticipating about how the other firms will act. And so today we'll try to look at a range of different ways of thinking about the monopoly problem, starting with the classical Cournot model, then talking about the sequential model of Stackelberg, and then using that as a motivation for the broader language of game theory, which we're not going to deal much with during this class. We'll then talk about the Bertrand-Edgeworth critique of the other oligopoly models, and then differentiated products models as a solution to that critique. We'll talk about collusion and Stigler's theory of oligopoly, which is based around the incentives that firms have to collude, but the difficulty they have in achieving it, and therefore that there will be some factors that facilitate or hinder firms in their goal of achieving collusion. And finally, we'll wrap up by talking about conjectural variations as a summary of the degree to which firms collude. Okay. So the most classic model of oligopoly is the Cournot 1838 model. And Jackson, what is the Cournot model?
So the Cournot model is where all firms are deciding at the same time what their prices and quantity should be, given their expectation of other firms.
And what in particular do they hold fixed in their expectations about other firms when they change their production?
Fix their expectation of other firms' quantity.
Exactly. So that's the key feature of the Cournot model. Firms produce homogeneous goods, and they expect other firms to keep their quantities fixed, right? So there's n firms with a homogeneous product. I'm going to assume that they have constant marginal cost, but that's not necessary. Each firm is going to take the quantities of all other firms as given. This is sometimes called quantity choosing. But notice that's a little bit misleading. It's not that each firm chooses its quantity. It's that it takes as given the quantities of the other firms, rather than taking as given something else. The firm could choose the price, because price and quantity are just related by the demand curve, right? What really matters is that the firm takes as given other firms' quantities, right? Equilibrium is achieved when every firm maximizes its profits given the quantities chosen by other firms. So to formalize this, the profits that the firm make are going to be its quantity times the price that it gets, which depends both on its own quantity and the quantities of other firms, minus cost. So we're defining Q negative I to be the sum of all other firms' quantities, and capital Q to be the sum of all firms' quantities. So what's going to be the marginal revenue for this firm? Does anyone want to derive that? Yeah, Israel.
Lowercase q times the derivative of the price function plus the price function.
Exactly. Sorry, you're missing one thing. Price function minus cost.
Oh, minus cost.
Right? Except that that's not included here. I don't know. Oh, sorry, that's the marginal revenue. Yeah. No, you're right. Yeah, so this is right. OK, so the marginal revenue is going to be closer to demand than with monopoly. How do we know that? Well, each firm doesn't produce the total quantity that the industry has, right? And so the weight that we put on this term, which is the anti-competitive term, the term that leads you to want to have prices above cost, is going to be smaller, right? With symmetric firms, this is particularly easy. I sort of used lowercase and uppercase n interchangeably. I'm sorry about that. Each firm will have 1 over n of the total industry production. And so rearranging this and using the same logic we did in the monopoly case, we find that the markup is just equal to 1 over n times the inverse elasticity, rather than the inverse elasticity, right? So the markup is going to be much smaller than it would be when there was a monopoly, right? In monopoly, this would be 1. When there's a lot of firms, it'll get much smaller. Okay, so let's take a simple example with constant unit elasticity of demand and a constant marginal cost of $1. Agnès, what is the form of demand when it has constant elasticity? When it has constant elasticity? Anyone else know what the formula? Yeah, mostly. Yeah, exactly. Because then P is equal, if P is equal to 1 over Q, then a 1% rise in Q leads to a 1% fall in P, right? Okay. So, I mean, you could also add any constant in front of this, and it wouldn't make any difference. But let's just leave it like this for now. OK, so if we take the derivative of price, right, then we get negative 1 over Q squared, right? So that gives us marginal revenue of this times QI plus the price itself, which is 1 over Q, right? So that gives us Q minus QI over Q squared, which is Q negative I over Q squared. OK. So each firm is going to set this equal to 1, which is their marginal cost, which is equivalent to setting 1 plus this equal to that, or satisfying this equation. Now I've isolated it so that the QIs are on one side and everything else is on the other side, so that it becomes easy for us to just add up across all of the firms, right? So where's Terrence? Terrence? No? So does anyone else want to just try adding that up across all the firms? Yeah, Kay.
Well, QI is just going to be Q over N, right? So then,
yeah.
So then you have 1 over QN equals 1 over Q minus 1. So then,
if you multiply that by N to add up across all the firms, what do you get?
So 1 over Q is equal to N over Q minus N. So
yep. Exactly. So 1 over Q is equal to N over Q minus N. So multiplying both sides by Q, we get 1 is equal to N minus NQ, or Qn is equal to N minus 1, or Q is equal to N minus 1 over N. Right? So quantity goes to the efficient level of 1. Why is 1 the efficient level? Well, if the price were equal to cost, then quantity would have to be equal to 1 to satisfy that equation, right? So quantity goes to the efficient level of 1 as the number of firms gets larger. On the other hand, output per firm, which is Q over N, or N minus 1 over N squared, is going to go to 0. And that's what's going to drive the price down to cost, right? Is that as the number of firms gets large, while the total quantity rises, the per firm quantity falls, and therefore the firm's incentive to raise its price above cost falls, right? Now, when there are just 2 firms, we can represent this in a simple way graphically. Does anyone know how to do that? Well, what we can do is note that for each firm, right, it's going to set QI over QI plus QJ squared plus 1 over QI plus QJ minus 1 equal to one another, right? So we can then solve that out for the value of QI, right? So just writing this out, doing multiplying by this squared and doing everything out, we get this quadratic formula, which gives us the solution that QI is equal to negative QJ plus the square root of 2QJ squared plus QJ, right? So that says if the other firm's quantity were something, what would I want to set my quantity equal to, right? This is called the reaction function. And this plays something like the role of like a supply or a demand relationship in these oligopoly situations. It says, given what the other person's doing, what do I want to do? But then I can also ask, given what he's doing, given what I'm doing, what does he want to do? And an equilibrium is an intersection between those 2 curves, right? So here it gives the example. If we have the quantity of firm I on the vertical axis, quantity of firm J on the horizontal axis, this gives the optimal quantity for firm I as a function of firm J's quantity. And this gives the optimal quantity for firm J as a function of firm I's quantity. And this is the optimal point. Okay. Now, Stackelberg argued that it need not be the case that both firms take the other quantity as given. One firm might think that if it sets its quantity, that the other firm will take that as given and may anticipate the reaction that the other firm will have to that in terms of how it sets its quantity, right? So in particular, if one company is big or in some way a leader, it may be able to commit to producing a certain amount of the good and therefore force other firms to react to that. And the question is, what incentives does that create? Saying? What incentive does the fact that I know that the other firm will react to the quantity that I set create for me as a firm choosing my quantity?
So if you know what the other firm will do,
Yeah.
then you can expect the demand function from their supply.
Exactly.
And since you have a demand function, you can maximize your profit.
Well, and in particular, how would you want to change your quantity, taking into account how the other firm will change its quantity? What direction would that go in?
So if other produce more, then I mean, if you set your other quantity, then the other will take it and use that quantity as a function, as a variable.
But what do you want to get the other firm to do? What's your goal? If you can affect the other firm's production, what would be your ideal situation? Like how would you like to affect what they produce?
I would like to lower their market share.
Yeah, exactly. Exactly. So you're going to do whatever it takes to cause the other firm's production to fall. So look at these graphs we had, right? I said that as firm I's production rises, firm J's production rises as well. So that's going to give me an incentive to reduce my production so as to induce the other guy to reduce his production. Now in other cases, say for a linear demand, you get the opposite effect, that as I increase my production, the other person reduces their production. And depending on which of those things happens, that's going to affect your incentive to change your quantity based on having this leadership position. Yeah, David?
Why is this phenomenon kind of isolated specifically for oligopolies? Why isn't it observable in a competitive market?
Because in a competitive market, I'm such a small part of the market that anything that I do won't affect either the prices or quantities of other firms because I'm so tiny.
Okay, I see.
Right? I take the prices as given. And once the price is given, I don't care what happens to other firms' quantities.
Okay.
Right? Okay. So the question is, does aggregate production rise or fall as a result of this incentive? What do you think, King Solomon?
Well, if you're using the graph that we just saw,
Yeah.
then the aggregate production would fall.
Yeah.
Because because both of them, if one person's quantity rises, then the other person's quantity rises as well.
Yeah.
So they would all want to reduce to
Yeah.
reduce the other person's quantity.
Exactly. In general, though, it depends on what's called strategic complements versus substitutes. Things are strategic complements if, as in the graph we just saw, when I reduce my quantity, the other firm wants to reduce its quantity. But with linear demand, or anything that's not log convex, anything that has a pass-through rate that's less than 1, you're going to, when I increase my quantity, want to actually reduce your quantity. And that would mean that you'd have an incentive to increase your quantity, which would increase the quantity of the industry as a whole. Because even though the other guy reduces his quantity, the first guy's increase in quantity makes a bigger difference, which you can show by the fact that the pass-through rate is always positive. So the quantity pass-through rate would also always be positive.